All right, now we're gonna move on to day 3. Now on day 3, if you are someone who has huge handwriting, this is not gonna be enough room. But if you have little handwriting, you can fit it there. So if you need some notebook paper, grab some notebook paper, because there is definitely a little bit of work that goes into this. So we're gonna talk about writing inverse equations. So remember, logs and exponentials are inverses of each other. So if I'm starting with an exponential, like I am on this, I should finish with a log. If I'm starting with a log, I should finish with an exponential. All right, so your first step, anywhere that you see f of x, those are y's. So this is a y, this is a y, this is a y, all of these are y's, all right? So instead of f of x, we're gonna take y. Now, remember, when you are doing inverses, your very first step is that you're going to flip your x and you're going to flip your y. So now it's going to be x equals 10 raised to the y. And then step 2 of finding your inverse is that you're always trying to solve for y. Now, if you want to change this order just so it stays in the same order that we've done other ones, you can flip-flop it. They're the same thing. And then if you're solving for an exponent, the only way you can do that is to create a logarithm, all right? So we're going to rewrite, and we're going to have log. This is the base of our exponent. That means it's the base of our log. These play flip-flop, and we end up getting this. Now, I do not want this to be your final answer. I want there to be 2 things that you change. All right, 1, when you do inverses, you need to signify that by having that raised to the -1. That means that you did the inverse. The next thing is that we don't want log 10, because we know that log 10 is just log. And so that would be your final answer. All right, same thing on the next one. So flip x, flip y. So you're going to have x equals e to the y. You can keep it in that order or you can change. It doesn't matter. So if I keep it in this order instead of rewriting, I know that the base of my exponent becomes the base of my logarithm. And then I know that these play flip-flop. All right, so this is going to come down here, and this is going to come over here. So always, again, your base becomes here, and then this comes over here. This is the same thing as e to the y is equal to x. Again, if the order is messing with you, then go ahead and write it in, like flip the order right off the bat. Now again, 2 things that you need to change before this is your final answer. 1, we are not doing log e. We're going to do the natural log. And we're not doing just y. We're going to say is equal to y prime. Okay, now let's get into one that's a little bit trickier. So those were pretty simple. Now let's do one that's a little bit harder. So if you look at 7, process stays the same. Let's rewrite. So I'm going to go ahead and I'm going to flip the order of these 2 right off the bat. So I'm going to come over here. I'm going to have 2 raised to the -y plus 3 minus 6 is equal to x. So I took my x's and y's and I just flipped the side that they were on. All right, now you cannot go straight into doing a log at this point, because at this point you still have this -6 that's hanging over there with your exponential. All right, and that cannot happen. You need to completely isolate your exponential. So this needs to be completely isolated on one side. So we're going to add 6, and we're going to have 2 raised to the -y plus 3 is equal to x plus 6. Now that you've isolated your exponential, now you can rewrite as a log. So this is going to become log our base of 2, and then we're going to flip. This becomes your argument, x plus 6. Your exponent becomes what it is equal to. x minus, or y minus 3. Then you just go back and you try to solve just like you would. All right, so if we were trying to solve, we would subtract 3, log base 2 of x plus 6 minus 3 is equal to negative y. And then I would divide by negative 1, divide this whole side by negative 1. All right? So if I divided this whole side, I'm going to end up coming up here. You would end up having log base 2 of x plus 6 is going to be, well, maybe I can sneak it in here down at the bottom. This is going to end up being negative log base 2 of x plus 6. And then negative 3 divided by negative 1 is going to end up being a plus 3. And that is going to equal y prime. This would be your final answer. Should have written a little bit smaller. All right, and then I'm gonna go ahead, I'm gonna leave 8 for us to do in class tomorrow. Again, if you're feeling good, go ahead and try to do it. Your final answer should have a natural log in it because we're talking about e's, but you should be able to work through that. And then I'm gonna go down, I'm gonna do 9, 10, and 11 so you can see the opposite way. So if we were to do the opposite way, all right, you're still gonna start with the step of flipping x and y. So this is gonna be x equals log y. Again, sometimes you guys are just used to having that log on the left side. So if you want to flip-flop the order so that you can see that, and then we're going to work from there. So if we're trying to solve for y, we got to get rid of that log. The only way we can get rid of that log is to change things into exponentials. So if I don't see my base, I know that this is base 10. And then these play flip-flop. So x equals y. Again, we're not going to leave it as y. We're going to write that this is y prime is equal to 10 to the x power. Ten, you should be able to do your own on your own too. So again, we're going to flip our x. We're going to flip our y. And then I'm going to rewrite with my logs on the left side so that everything stays in the order that I've been doing it. If we want to solve for something inside a natural log, again, the only way we can do that is to go to exponential. So we don't see our base here because it's a natural log, so that's going to become an e raised to the x is equal to y. So we're going to have y prime is equal to e to the x. If you keep it in the other order and do e to the x is equal to y prime, it's the same answer. So you can write it either way. And then the last one that we're going to do is number 11. So number 11, again, a little bit bigger of a problem. So let's start by flipping our x and y. So we're going to have x equals log base 2 of y plus 3 minus 2. And then I'm going to flip the sides that they're on. Again, so my logs are on this side. Just like I told you up here on this problem, that you couldn't go straight into changing from exponentials to log when we had that minus 6. The same thing is here. You can't go from logs to exponential when I have this minus 2 that's not part of the log. All right, so I need to isolate this first. So I'm going to add 2, add 2. That's going to give me log base 2 of y plus 3 is equal to x plus 2. Now you can go ahead and rewrite. So our base is 2. So 2 raised to the x plus 2 is equal to y plus 3. Last step to solve, we would subtract 3, and we're going to have that y prime is equal to 2 raised to the x plus 2 minus 3. All right. We will do 8 and 12 tomorrow in class, so if you have any questions, make sure you guys are asking questions. All right. Make sure you guys are getting ready for that quiz because you guys got a quiz coming up.